of the chain rule. And then we saw that there were 3 other versions of the chain rule. We had the power rule version, which said that if I have some function to a power, and so here the main thing was that we had a function to a power, then we just bring in down g of x to the n minus 1, and then we pull out g prime of x. Then we had e to a function. So again, here our g of x was like a function that was a power of e, and we just rewrote everything and multiplied by g prime. And we had the same thing for a. Again, our g is there, and this is a to the g of x times ln a. And then we also had our log rules. So we had ln, instead of having x, we have a g of x on the inside. So again, our g of x in this case is there. And this became g prime of x over g of x. And then we had log base a of g of x, which was g prime of x over g of x ln a. And so these were like the different versions of this main chain rule that we had up there. Today I'm going to start off with kind of a more abstract problem to see if we can make sure that we understand this in the abstract and not just concretely. And then we're going to go on and do some actual problems. So hang on. Be a 2 there. Okay, I think I have everything that we need there. I can't read my notes, so that's great. Okay, so if we have all of these things, then we're going to start off by evaluating just f of g of x, the derivative of that, at x equals to 2. And so if we use the rules that we have up there, we know that f of g of x is equal to f prime of g of x times g prime of x. And we want to evaluate this at x equals 2. So that means I just need to plug in 2 to this equation. So this will give me f prime of g of 2 times g prime of 2. So like I said, we're just doing a little bit more of an abstract version of this. So I'm saying if I use the formula that I have, that we have up here, that we kind of memorized, hopefully, or will memorize, and instead of x, I have 2, then I can plug in that. But then I can see that I'm given that g of 2 equals 5, and g prime of 2 equals 6. So at this point, I can replace g of 2 with 5 and g prime of 2 with 6. So this leaves me with f prime of 5 times 6. But what was f prime of 5 equal to?
G of 2?
So f prime of 5. So f prime of 5, we plugged in the g of 2. That 5 came from g of 2. But f prime of 5 itself is 8. So that becomes 8 times 6, and my answer here is just 48. Okay, now if I were to ask you to find f of x cubed, I want the derivative of that at x is equal to 5. So again, here we're just applying a rule. Which one of my rules up here am I going to apply? We have 1, 2, 3, 4, 5 of them. So if we start at the beginning, the g of x to the n is 1, then 1, 2, 3, 4, 5. Which one of those 5 rules am I going to apply? Hang on, I'm going to number them. 1, 2, 3, 4, 5. So I have f of x to the power of 3. So which one of these rules am I going to apply? I see that some of you are responding in the chat, and it looks like you're responding with a 1, but it's kind of blurry, so it might be a 2. We're going to pretend it's a 1 because that is the correct answer. So exactly, we're going to apply the first one. And that first one tells me that I bring the 3 down, I don't touch what's inside, I subtract 1, and then I pull out f prime. But I want this at x equals 5. So that means I'm going to plug in 5 now. So I'm going to have 3 times 5 squared. I'm sorry, not 5 squared. What am I doing? Times f of 5 squared times f prime of 5. But what is f of 5? You got it, it's 1. So this is equal to 3 times 1 squared. And what is f prime of 5? Exactly, so I think you guys said 8. So that gives me an 8. So that's 3 times 1 squared times 8, which is 24. So we can see that even if we don't know what the actual functions are, we can still apply the chain rule and find values at specific x values. Are there any questions about this problem? All right then. So okay, so this kind of gives us an abstract way of thinking of the chain rule. I want to go back now and actually start using the chain rule. So yesterday we learned the chain rule. We saw the chain rule in lots of different circumstances. We did problems for each of the different types of chain rule that could happen. Today we're going to see that sometimes a chain rule can occur inside of a product rule or a quotient rule, or sometimes inside the chain rule. You might have a product rule or a quotient rule. So we're going to do the chain rule combined with those two rules. So in order to do this, let's just remind ourselves briefly of the product rules, of the product rule. So that's fg prime is f prime g plus fg prime. And the quotient rule is f over g prime is equal to f prime g minus fg prime over g squared. So this is the product rule, and this is the quotient rule. Okay, so let's just do a few examples where we see this, and hopefully for those of you that are struggling with the chain rule after yesterday, this will be helpful, because then we're going to see a chain rule inside of a chain rule. Okay, so we have f of x is equal to e to the x plus 2 times x squared plus 1 all to the power of 5. So what I want us to notice here, do I have a function to the power of 5 or just x to the power of 5? Got it, I have a whole function. So this right here is a whole function to the power of 5. So I can kind of see this as being a g to the power of 5. I have my whole function to the power of 5 there. So that function inside is my g. Does this mean that I need to apply a chain rule? Yes. Anytime we have a function instead of an x, that's a sign that we apply the chain rule. So I'm going to do this exactly the same way that we did yesterday. I'm going to bring the 5 down, e to the x plus 2 times x squared plus 1. The new power is going to be 4, and then I bring that inside function to the outside and I prime it. Except now that when I look at this inside function, so the thing that I primed on the outside, I need to pretend that it's like my initial function. Every time you do a rule, like the product rule or the quotient rule or the chain rule, you're going to have something that you pulled out that's still primed, that you still have to take the derivative of. And you should always treat that as if it is the initial problem. So you're going to look at it and you're going to evaluate again, how do I do this derivative? So if all I had was e to the x plus 2 times x squared plus 1, what rule would I need? How would I do e to the x plus 2 times x squared plus 1? I can't actually read that. Good, okay. I think you said the product rule. Okay, exactly. So do I have a thing where I can insert a times in between? E to the x plus 2 times x squared plus 1. That times tells me I should do a product rule. I have an f here times a g there. So we're going to make a little note on the side. Every time you apply a rule and end up with a new prime, we want to treat it as if it's the original derivative. And we're going to ask, does it need a product rule, quotient rule, or chain rule? And in this case, we've identified that it needs a product rule. Okay, so we've identified that it needs a product rule. So we're going to apply the product rule, but just to the part that's primed. Remember, everything else that's there just stays the same. So I have f prime of x is equal to, I'm not touching this original thing, e to the x plus 2 times x squared plus 1, all to the power of 4. And then I'm applying the product rule inside this thing. So the product rule says the derivative of the first, so the first prime times the second, plus the first times the derivative of the second. And so when I've applied that product rule, I now have two primes left, two things left for which I need to take the derivative. And I'm going to do the same thing. I'm going to ask myself, okay, so that e to the x plus 2, does it need a product rule, a quotient rule, or a chain rule? Yes or no? No, it's just a simple derivative. It's one of our original derivatives that we found where we can just write down the answer. What about x squared plus 1? So then we move over to that. Is that going to need a product rule, a quotient rule, or a chain rule? Also, no, that's one of our original derivatives. It's really straightforward. It's just going to be 2x. So now for this last thing, I don't have any rules left to apply. So I get f prime of x is equal to 5 e to the x plus 2 x squared plus 1 all to the power of 4 e to the x times x squared plus 1 plus e to the x plus 2 times 2x. And that is my final answer. And what we did here is a product rule inside a chain rule. Are there any questions about this product rule that we just did inside a chain rule? Okay, so then let's look at this next question. 5x ln of x squared plus 2. What rule do I need to do this derivative? Do I need a product rule, a quotient rule, or a chain rule? What do you guys think? Come on, guys. What do you guys think? Think about how we've been asking ourselves, what do chain rules look like? What do product rules look like? What do quotient rules look like? Do I need any of those rules to do this? Okay, so I see a chain log rule. For sure, I'm going to need a chain log rule because I have a sort of g inside of my log there. But do I only have a log here? Or am I multiplying that log by something else? Are you guys feeling like I am today? You got it. I'm going to need a product rule here as well. And that product rule is going to come before my log rule because the log is one of the things that's being multiplied. So here what I have is 5x times ln of x squared plus 2. And when we can insert the word times in there, that tells me that I need a product rule. And my f is that 5x, and my g is the ln of x squared plus 2. So I'm going to immediately apply my product rule, which says the derivative of the first times the second plus the first times the derivative of the second. And so when I applied that product rule, I have two things primed in my product rule. So I have two things for which I need the derivative. And so for both of those two things, I'm going to ask myself again the same question. Do I need a product rule, a quotient rule, or a chain rule? So what about for 5x? Do I need a product rule, quotient rule, or chain rule? Nope. That's pretty straightforward. It's simple. Then what about ln of x squared plus 2? Yes, that one is going to require a chain rule. So this chain rule wasn't the first thing that happened. It's happening inside of my product rule. So then g prime of x, the derivative of 5x is 5, times ln of x squared plus 2. So I'm actually going to write that without the parentheses. 5 ln of x squared plus 2 plus 5x. And then this is a log chain rule. So the x squared plus 2 goes on the bottom, and the derivative of x squared plus 2 goes on top. And now I have one prime left here. It's x squared plus 2. So I ask myself again, do I need a product rule, a quotient rule, or a chain rule? Do I need any of those things? No, I do not. X squared plus 2 is just a simple 2x. That's one of my original derivative rules. So then this becomes 5 ln of x squared plus 2 plus 5x times 2x over x squared plus 2. And that's my final answer. And if you wanted to get 10x squared on the numerator there, that would be fine. Okay, so in the first thing, we had a chain rule, and inside of a product rule, and inside of that product rule, we had a chain rule. Whereas this time, we had a product rule, and inside of that product rule, we had a chain rule. So we started off with the chain rule, and then had a product rule. We started off with the product rule, and then had a chain rule. And do you guys see the difference in how we figured out which one to start with? Any questions about the difference between these two things?
Yeah, I don't see the difference. Like, why did you do one first and the other one second?
Okay. So when you look at the first problem, I can look at that as g to the power of 5. Every single thing I have there is to the power of 5, right? So I have this function to the power of 5. So far, so good?
Yeah.
Yeah. Okay. Yeah. And then that function itself, it turns out that that g is a product. So the first thing I have is a function to a power. But it just so happens that that function is a product. Whereas here, do I have everything to the same power? No. Is everything inside of my ln? This isn't like this. It's not like I have 5x times x squared plus 2 inside of my ln. That 5x is on the outside of my ln. The only thing I have here, if I were to rewrite this, it would kind of look like 5x times ln of g. So that g is not to a power, it's just inside my ln, but then I have this other thing that has nothing to do with it. Does that help?
Yeah, thank you.
Okay, let's do the same thing with the quotient rule, and hopefully that's going to really help this to make some sense. what rule do I need to use here? Product rule, quotient rule, chain rule, none. You got it, Jenny. We're going to do a chain rule, a quotient rule. And the quotient rule happens because even though I have this function to the power of 6, not everything is to the power of 6, only the numerator is. So I have a thing over a thing. It's not like I have all of this to some power, right? It's not like it's all inside of a ln. It's not like it's all the power of e. I just have a function over a function. So that tells me that I'm going to need a quotient rule. So we're going to start off by applying that quotient rule. So the quotient rule says the derivative of the top times the bottom minus the top times the derivative of the bottom, all divided by the bottom squared. So now inside of my quotient rule, I have these two other things being primed. Two other derivatives left that I have to take. Okay, so then for each of those things, I ask myself the same question. Do these things need a product rule, a quotient rule, or a chain rule? So first I have x squared plus pi x plus e to the power of 6. What does that need? You got it, Mikhail. That's going to be a chain rule because here it's like I have a function, so I have my g to the power of 6. And what about over here, e to the x cubed plus ex? What's that going to need? Chain rule, product rule, quotient rule, none. It's also going to be a chain rule because here it's like I have e to the power of a function. So that function up there, that's my g. And this function on the inside, that's my g. Okay, so then when I'm applying those rules, I'm going to apply the chain rule to each of those. No, it's supposed to be ex. I just, it's not supposed to be e to the x. Does it look like an e to the x? It's kind of hard for me. I'm only like half seeing everything I'm writing. Oh, that does kind of look like an e. Let's make that really clear. That is supposed to be an ex there. Yeah, that was supposed to be e times x. I just can't actually really see things very well today. So now we're going to apply our chain rule. And my chain rule tells me, take this 6, bring it down, don't touch what's inside, to the power of 5, and then that g, I'm going to pull it to the outside and prime it. And then the same thing over here, x squared plus pi x plus e to the 6. And hang on, that's my doorbell. I'll be back in 2 seconds. Maybe you guys can try to finish this up. Sorry about that. Ouch. Okay, so now we're doing the chain rule that was with my e, and we know that for that, e to the x is just e to the x, so nothing changes here. So this is just e to the x cubed plus ex, but I have to multiply by the derivative of my power, so of my g, so that times the derivative of x cubed plus ex. So then we're going to prime that as well. E to the x cubed plus ex squared. Okay. Now, once again, I have two things left in this answer that have primes, two derivatives that I have left that I need to take. So again, I ask myself, chain rule, product rule, or quotient rule? So for this first one, x squared plus pi x plus e, do I need a chain rule, product rule, quotient rule, or none? Good job. None. What about for x cubed plus ex? Chain rule, product rule, quotient rule, or none? Also none. So that means this next step is going to be my last step. I don't have any rules left that I'm applying here. So I will have h prime of x is equal to 6 x squared plus pi x plus e to the 5th. Now this is just a simple power rule, so I'll have 2x plus pi e to the x cubed plus ex minus x squared plus pi x plus e to the 6 e to the x cubed plus ex. What's the derivative of x cubed plus ex? You got it, 3x squared plus e. Good job, guys. And so now I don't have any primes left. Oops, that is my final answer. So this one was a chain rule that happened inside of a quotient rule. So I started with my quotient rule, and inside I discovered, oh look, there's the chain rule. So fun, there were two of them. Okay, we're gonna do one more of these before I'm gonna give you guys like a find the mistake question, and then we're gonna do a chain rule inside of the chain rule. So we will have f of x is equal to e to the x plus 7 over x squared plus 9x to the 8. So do I have a quotient here? Is that whole quotient all to the same power? It's all to the power of 8. So it's like I have this g here, and that g, that inside thing, is all to the power of 8. So really I could think of this as g to the power of 8. Exactly. So I'm going to be doing a chain rule here, where that inside function, that quotient, is my g. So my f prime of x, I'm going to move the 8 down. Remember, I don't touch what's inside. I'm just applying my power rule, e to the x plus 7 over x squared plus 9x to the power of 7. And then that inside thing, I pull to the outside. And I put a prime. And I have one thing prime, so one derivative I need to take. And I ask myself, do I need a product rule, a quotient rule, a chain rule, or none? You got it. This is going to be my quotient rule. So I'm going to apply my quotient rule to this. I have an F and I have a G. So I'm going to do 8. I don't touch what's inside. To the 7. And then my quotient rule is going to go in these parentheses on the outside. The derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Do I have some primes left? Yep, I've got 2 of them. So I have 2 things, 2 derivatives I need to take, and I ask myself, e to the x plus 7, product rule, quotient rule, chain rule, none. None, you got it. X squared plus 9x, product rule, quotient rule, chain rule, none. Also none. First one's a simple exponent rule, the second one's a simple power rule. So then this becomes f prime of x is equal to, so because I'm not going to be doing a product, quotient, or chain, I know that this is going to be my last step. So 8 e to the x plus 7 over x squared plus 9x, all to the power of 7, e to the x times x squared plus 9x, minus e to the x plus 7 times 2x plus 9, all divided by x squared plus 9x squared. And that's my final answer. And ultimately what happened here is my main rule that I applied was a chain rule, but inside of that chain rule, I had a quotient rule. So this was a quotient rule in a chain rule. How you guys feeling about this stuff? Good, bad, happy, sad? Is it starting to click a little more than it was yesterday? Or did we confuse you even more? A little of both, okay. Okay, well, what we're gonna do now is, I wanna do a chain rule and a chain rule. I really wanna make sure that we have time to get to that today, but I also wanna just kind of see where you guys are. So what I'm gonna do now is a find the mistake problem. I'm gonna write 3 functions and I'm gonna write 3 derivatives, which are all wrong. And in the chat, privately, I want you to identify the mistake for each one. And I'm gonna give you guys about 5 minutes to do it, so you probably won't have time to finish, but I want you to be thinking about all of them. Does that make sense? So here we are identifying the mistake. Okay, so like I said, in the chat, privately, I want you to identify the mistake. I'm gonna give you guys, it's 18. I'm gonna give you guys till 23 to do this. Okay, so one of them has 2 mistakes. So just tell me A, blah, 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 and I'm gonna do my best to read the chat. It's, actually, it's getting less blurry, that's good. I'm gonna press pause while this is happening. Record. So we just kind of went through and identified the mistakes there. Now, what we are gonna do is we're gonna add to this. So we've seen how chain rules and product rules and quotient rules can all be mixed together. Sometimes we might have a chain rule inside another chain rule. Or rather, we'll say chain rule multiple times. And this really isn't going to change how we think about the problem, because we know that every single time we have a prime, we're re-asking ourselves the question, what rule do I need? Do I need a product rule, a quotient rule, a chain rule, or none? And we're going to keep asking ourselves that. So we're going to start off with something that's really simple that maybe doesn't require a chain rule or a multiple chain rules. So I have ln x to the power of 9. I'm going to give you guys a second to get that down, and then I'm going to go back to the top of the page. So to do the derivative of ln x to the 9, oops. 1, 2, 3, 4, or 5, which one of these rules should I be using? Okay, I'm gonna go back and look at the problem again. Look at 4. 4 says ln of a function. Is that what I have here? Do I have ln of a function? I don't. So this is not going to be 4. We're not using 4 here. Which one am I using? 1. I'm using 1. That ln is to a power. It's not ln of x to the 4th. It's ln of x all to the 4th. The ln itself is to the power. So what I have here is like g to the power of 9. You guys see that? And how we're using 1 here and not 4? So what that means is f prime of x, I bring the 9 down, I don't touch what's inside, I subtract 1, and then I pull out the derivative of the inside. Now, this inside function, I ask myself, product rule, chain rule, quotient rule, none. None. This is just a simple rule. The derivative of ln is just 1 over x. So this will be 9 ln x to the 8 times 1 over x. How many times did I use the chain rule? Did I use the chain rule 1 time, 2 times, 8 times? I used it 1 time. Okay, let's change this up just a little bit. Let's say that instead of having ln x on the inside there, I have ln of x squared plus pi x plus e to the x, all to the power of 9. Is this the same thing? Am I going to start this the same way that I started the previous question? Do I still just have a g to the power of 9 here? It's a different question, but this whole ln right here, is it all to the power of 9? It is. So once again, I'm not using 4. I'm not starting with 4. That's going to come later. I have ln of g, but that whole thing is to the power of n. So this is actually 1. I have a function that's to the power of 9. Doesn't matter what that function is. I've just identified I have a whole thing that's to the power of 9. So once again here, I can think of this as g to the power of 9. So then when I do g prime of x, I'm going to start off the same way. I'm going to bring the 9 down. I'm not going to touch what's inside. I'm going to subtract 1. But now the thing that I pull to the outside now, is that a 4? Now do I just have ln of g? I do. Now that's like a g inside. So I have this new prime and I ask myself, does this require a product rule, a quotient rule, a chain rule, or none? And we can see that this is like the fourth thing that I have up here. This is ln of a function. So this is another chain rule. So I started with a chain rule, and now I have another chain rule that I'm going to have to do inside of my chain rule. So then g prime of x, I don't touch all of that original stuff that's not being primed. So it's ln of x squared plus pi x plus e to the x, all to the 8, only now I'm applying my chain rule. For ln, it says to do g on the bottom and g prime on the top. Okay, so far so good. Are there any questions about what I've done so far? Okay, now I'm looking at this. I have x squared plus pi x plus e to the x. Does that require a chain rule? Do any of those require a chain rule? Nope, so this is not a product rule, not a quotient rule, not a chain rule, just straightforward power rule, exponent rule. So then this becomes 9 ln of x squared plus pi x plus e to the x to the 8 all times 2x plus pi plus e to the x over x squared plus pi x plus e to the x. And I don't have any primes left. That's my final answer. So this, the first one was 1 chain rule. The second one was 2 chain rules. Are there any questions about how I identified those 2 chain rules and how I went about approaching the problem? Okay. Do you think I could have more than 2 chain rules? I can. I can have 3 chain rules or 4 chain rules or 5 chain rules or 6 chain rules. Really, I could have infinite. It would be really gross, but I could totally have as many chain rules as I want. So we're going to do one more here that has 3 chain rules, and that looks really similar. And then we're going to look at a problem that looks totally different just to kind of make sure that we really understand how this process generalizes. Is this pretty much the same problem? Yeah. So do I once again just have g to the power of 9? Yes. So I'm going to start this off exactly the same way. G prime of x, I bring my 9 down. I don't touch what's inside. I subtract 1, and then I pull out the inside function. And is that inside function going to require a chain rule? Yep, I have a chain rule there. That's my g. This is a chain rule. And it's a log chain rule, so like, it's kind of like I have ln of g here, ln of g. So then h prime of x is 9 ln of x squared plus pi x plus e to the x cubed plus 4 to the 8. I have g on the bottom, x squared plus pi x plus e to the x cubed plus 4. And then on the top, I have that primed. And so now I'm looking at this thing. And once again, I ask myself the same question. Does this require a product rule, a quotient rule, or a chain rule, or none? And with x squared plus pi x, we're fine. But what about e to the x cubed plus 4? Am I going to need a chain rule on any of those things? Yes. What do you mean, Jenny? Why is it g prime? Why is what g prime? So here I have e to the power of g. So I'm going to need a chain rule for just this part. And Jenny, if you would like to explain your question, you are welcome to. I don't understand it. So what that means is I'm only doing a chain rule on that part. The other part, so this is like what we did yesterday when we have pluses, we have to look at each term and say, do I need a chain rule? Do I need a chain rule? Do I need a chain rule? I don't need a chain rule on x squared. I don't need a chain rule on pi x, but I have e to a function. Oh, I see what you mean. There you go. Okay, so h prime of x is 9 ln of this inside thing, x squared plus pi x plus e to the x cubed plus 4 to the 8. I'm not touching the bottom. And then what's the derivative of x squared? Tell you because I want to have time to do another problem. 2x. The derivative of pi x is pi, but now I have e to the g. So this is plus e to the x cubed plus 4 times the derivative of x cubed plus 4. And now I have this other prime. And I'm pretty much done with the problem because the derivative of x cubed plus 4 is just 3x squared. So we really don't have anything left to do. But notice I only applied the chain rule to that one part of the addition there. And this is my final answer. And this required 3 chain rules. Have I lost you guys yet? These embedded chain rules can get a little confusing. Okay, so we're going to do one last question here. And then tomorrow, we're going to learn how to simplify so that on, actually, no, I don't know. We'll either learn how to simplify tomorrow and do trig Thursday, or we'll do trig tomorrow and simplification Thursday. But we have trig and simplification left to do with this. You guys excited to add trig in? Oh, yeah. Okay, any questions before we do one last problem here? All right, then. We'll call this one P of x is equal to e to the square root of e to the 2x plus, or sorry, minus 4x. All right, I have a square root here. So the first thing I want to do is rewrite it. So I have e to the 2x minus 4x all to the power of 1/2. I'm going to go back to the top, and I want you guys to tell me 1, 2, 3, 4, or 5, which one of the rules should we be using? So e to the power of 2x minus, e to the 2x minus 4x to the 1/2. Which one of these things? 1, 2, 3, 4, or 5? I'll wait for a couple more people to answer. All right, most of you are saying 2. That is the correct answer. I have e to a function here. So this is like e to the g. So hands down, I'm going to be doing a chain rule. So this is like my g. So p prime of x is, I don't touch what's up here. I rewrite exactly what I have. So I have e to the 2x minus 4x to the 1/2. And then e to the 2x minus 4x to the 1/2 prime. So now I'm looking at this. And I'm going to go back up there and see, do I need a product rule or a quotient rule? No, this isn't a product, it's not a quotient. E to the 2x minus 4x to the 1/2. Do I have one of these things going on? Do I have a number to a function, or do I have a function to a number? I have 2 answers. There are 19 of you. I have a function to a number. So a function to a number, which one of those things is this going to be? 1. Exactly. So now we're doing 1. So this is another chain rule. My g is that function that I have inside. It's not x to a number, it's a g to a number. So this is e to the square root of e to the 2x minus 4x times 1/2 e to the 2x minus 4x to the negative 1/2. And then I have to pull out that inside function, prime. So now I'm looking at this. And guys, I want us to be able to go in like 2 minutes. So does this need a chain rule? Yes or no? Tell me fast.
No. No.
Yes. So you got to be careful because in this case, it's easy to think that it doesn't. But this 2x right here is not just x. So what I have is another e to the g. It's not e to the x, it's e to the 2x. 2x is a whole function. So we've got to really be careful about that. So I need another chain rule just on that part. So I'll have e to the square root of e to the 2x minus 4x times 1/2 e to the 2x minus 4x to the negative 1/2 times, I'm doing my chain rule here, e to the 2x. I'm just going to write it. Derivative of 2x is 2 minus 4. So that right there, that's where we did the derivative of 2x, and I had 3 chain rules again. And that's my final answer. And we are done. Like I said, we're working on this for the rest of the week. This is not easy stuff. It is normal if you find this a little overwhelming. Like, this can be hard. We're going to keep working on it for the rest of the week. We're going to get you there. If you have any questions now is a good time to ask.